So for week 7 of EE6301, Feedback and Control Systems, we are going to discuss second order linear system, transient response analysis. So in second order system, as you can see in the figure or the block diagram below, we have there an RS or reference input signal that will undergo a summing junction. So yung summing junction natin is composed of positive and negative signal, and meron tayong plant process or process na transfer function K over S multiplied to the quantity JS plus F. And meron tayong position signal C of S or yung pinaka-output function C of S natin. So meron tayo din diyang, meron din tayong feedback path. Yung feedback path natin will go back as negative signal ng R of S sa junction point natin or summing junction. So ano yung magiging equivalent transfer function natin for that? So magiging equivalent transfer function natin would be C of S over R of S is equal to K over JS squared plus Fs plus K. Paano po siya naging K over JS squared plus Fs plus K? It's because you will use a feedback signal. Yung feedback signal mo will come from the plant natin na K over S JS plus F. No? So upon equating the transfer function, no, so magkakaroon tayo ng second order system. So how do we obtain a second order system? So substitute natin yung mga transfer function. So we have here different equivalencies. So you have there K over J, which is equal to your omega sub n squared. Then you have F of J, which is equal to 2 zeta omega n is equal to 2 sigma. Then your zeta is equal to F over 2 square root of JK. Then what is the equivalencies of that? So yung ating zeta, yung parang C na cursive, so yung zeta natin is equal to your damping ratio. Then yung omega natin is equal to undamped natural frequency. So, undamped natural frequency, so yung omega n is yung natural. Then, yung ating sigma is yung stability ratio para ma-obtain natin yung second order function or second order system, which is equal to C of S over R of S, which is equal to yung ating omega n squared over S squared plus 2 zeta omega n S plus omega n squared. So, as you can see there, if there is S squared in your function or in your transfer function, automatically it makes your system the second order. So you have there three cases. You have the underdamped, critically damped, and overdamped. So pag sinabi natin underdamped is when the value that you will get is equal to, when the value that you will get is 0, then dapat siya ay, yung zeta natin is greater than 0 but less than 1. Okay, that's underdamped. So that is F squared minus FJK, which is less than 0. You have two complex conjugate poles. When it's critically damped, so your zeta must be equal to 1. Okay? Pag overdamped, your zeta should be greater than 1. So sa critically damped is yung F squared natin is meron tayong difference between two equal real poles. So you have F squared minus FJK is equal to 0. Then overdamped is F squared minus FJK is greater than 0. So you have there two real poles. So that is, those are the three cases that you need to consider when it comes to second order systems. So what is the transient response specifications when it comes to feedback? So you have there unit step response of a second order underdamped system. So sa underdamped natin, as you can see, meron ka dyang X and Y, which is correlating to different parameters. So this transient response curve is described by this equation. So as you can see, yung flow ng ating graph is meron tayong mga parameters na need na i-consider. So you have their TR, TP, TS, you have MP, and TB. So lahat yan ay may coequivalence definitions. Okay? So as you can see here, yeah. So meron tayong exponential rise ng ating graph, then bababa siya to a point na mas mababa siya sa 1. Tama po ba? So dahil nga nag-raise siya, then bumaba sa 1, then magkakaroon tayo dito another raise or another rise dito wherein meron tayong allowable tolerance which is 0.05 or 0.02. In order for you to get the equation of this transient response, okay, so you need to have the value C of t is equal to 1 minus t negative zeta omega n t multiplied to the quantity cosine omega d t plus zeta over 1 as square root of 1 minus zeta squared sine omega dt, where our t is greater than or equal to 0. Now, baka tanungin nyo, sir, paano po namin gagamitin yung equation na yan? So you need to have an equation that is relative to your parameters. So pag nabigyan kayo ng proper example and proper given, so masasolve nyo na siya. And of course, some of the values there are substitutional. So ano yung mga ibig sabihin ng ating mga letters dyan kanina na diniscuss natin? So yung TD natin is yung ating delay time. So as you can see, hindi pa siya nagre-reach ng 1 wherein nag-exponential rise pa lang siya. This is the time of reach 50% of our C infinity for the first time. Yung TR naman natin is yung with respect to your x-axis, this is the rise time. Time to rise from 0 to 100% of your C infinity. Then yung TP natin, again, at X natin, is the time required to reach the first peak. Kasi po, kaya yung TD, TR, and TP, para hindi nyo makalimutan, so that is with respect to your T, or yung X-axis natin. Di ba na-discuss natin na yung flow of signal natin is with respect to time. So kailangan yung TR, TD, and TP mo is horizontal or with respect to your X-axis. MP naman natin is yung tinatawag nating maximum overshoot. So yung maximum overshoot natin is yung difference of your signal with respect to 1. So mangyayari dyan is you will solve for that as the C multiplied CTP minus C infinity over C infinity, which is equal multiplied to 100%. So yung C infinity natin is yung pagdiretso ng ating signal with respect to your y-axis. ES is yung settling time natin. Yung settling time naman natin is the time to reach and stay within the tolerance level. So, pag nakita nyo na nakapasok na siya sa tolerance level niya, so that is yung settling time natin, which is 0.4 must be less than zeta, but zeta must be also less than 0.8. It gives a good step response for an underdamped system. So as you can see there, that is how you understand the underdamped system. So kailangan lang aware ka and you are familiar with the different parameters para pag nabigyan ka ng examples and definition, you can have an example for that. All right? Okay, so that is the end of our discussion for today.